Now we'll understand about the coaxial cabling. Coaxial cable is a thick shield wire with a central copper core used for TV, internet, and video signals. It resists interference better than twisted pair cables, but is less flexible, common in cable TV connections and older networking setup. So basically, these coaxial cables were used previously, around 5 to 10 years back. Okay, and you must have seen this kind of cable. Okay, we'll understand about the coaxial cable, the construction of it. The inner copper core, it is an insulation, metal shielding, and outer rubber jacket. You can see it says there is an inner copper core, okay, and there is an insulation as well. It is a metal sheet and outer rubber jacket. So these are the kind of pins that get attached to the socket like this. Now, S-type connector. It is a screw-on connector like those on cable modems or TV or set-top boxes. You must have seen in old TV set-top boxes or cable modems, this kind of pins were utilized in the socket. Okay, so now we'll understand about the wireless network types. Access point. What is an access point? Access point is a networking device that allows Wi-Fi devices to connect to a wired network, acting like a bridge between wireless and wired system. It broadcasts a wireless signal, enabling smartphones, laptops, and other devices to access the internet or local network. Unlike a router, an access point doesn't assign IP addresses. It extends existing network coverage used in homes, office, and public spaces to improve the Wi-Fi range and performance. Multiple access points can work together to create a seamless, large-scale network. So what is IEEE 802.11? That is the Wi-Fi. It is a standard for Wi-Fi networking that enables device to connect to network without cables. Infrastructure mode WLAN. It is a wireless network where devices like stations are connected through an access point instead of directly to each other. Access point interconnects wireless clients. Here, the access point acts as a central hub, linking the Wi-Fi devices like phones, laptops to the network. Infrastructure Basic Service Set, that is BSS, in a single access point and its connected wireless devices from the basic network unit. Basic Service Set Identifier, BSSID. It's a unique identifier for a BSS. It's the MAC address of the access point's radio. It can also bridge with wired network via a switch. The access point connects Wi-Fi clients to a wired network like Ethernet through a network switch. Now let's understand about 802.11a and the 5 GHz frequency band. We'll first understand about the 2.4 GHz. It's a better range and wall penetration, but fewer channels, like more interference from devices like microwaves. In 5 GHz, it is actually faster speed with less interference, but shorter range and weaker through walls. IEEE 802.11a, 54 Mbps. Early 5 GHz Wi-Fi standard with 23 non-overlapping channels uses DFS to avoid radar interference. Dynamic frequency selection, DFS, automatically switches the channels to avoid conflicts with weather, military radar required by law in some regions. Now let's understand about this diagram. The diagram shows 5 GHz Wi-Fi frequency bands and other channel allocations. UNI I1, UNI I2, these are the standard 5 GHz ranges, channel 36 to 34 with 20 MHz wide. UNI I2 extended, it's an additional channel with 100 to 140 or 149 to 161. Some requiring DFS to avoid radar interference. UNI I3 channel from 149 to 161. Let's move ahead. 802.11n. Okay, so 802.11n, that is Wi-Fi 4, is a wireless standard that boosts speed up to 600 Mbps and required by using multiple antennas. It works on both 2.4 GHz for better range and 5 GHz for less interference bands. It combines channels for faster data like 40 MHz width, backward compatible with older Wi-Fi. These are basically faster, more reliable connection for streaming and gaming. So mostly we are using this 5 GHz or 2.4 GHz in our daily office or home network. So multiple input and multiple output, MIMO. So MIMO uses multiple antennas to send and receive data simultaneously, boosting Wi-Fi speed and reliability. It reduces dead zones by improving signal strength and handling interference better, found in modern routers like Wi-Fi 5, 6 for faster streaming and gaming. It can transmit around 72 Mbps per stream. Now we'll understand about the wireless LAN installation and configuration. Network name or service set SSID, frequency and band use, and channel usage. So what is SSID? SSID is nothing but your network name, the Wi-Fi name you see when connecting to the network, example home Wi-Fi, office Wi-Fi, guest Wi-Fi connections, etc. After that, frequency band use. Frequency band use is like Wi-Fi runs on 2.4 gigahertz for longer range or 5 gigahertz for faster speed. The frequency band use same SSID or different SSID per band, using one name for both bands for seamless switching or separate names. Example, home Wi-Fi 2.4G or home Wi-Fi 5G. Operation mode. It lets older devices, Wi-Fi 4 or 5 work, but only slow near networks. Now, let's understand about the channel usage. It is a Wi-Fi lanes like radio stations that picks the least crowded one, avoid interference. So this lane usually avoid all kind of interference. It is a non-overlapping. It is a kind of unique lane. For example, 1.6.11 in 2.4 gigahertz that don't interfere with each other. Channel width rebonding. It combines the lanes as well. For example, 40 megahertz versus 20 megahertz for faster speed, but fewer channel availables. Now let's understand about the next topic, Bluetooth, RFID and NFC. So what is Bluetooth? It is a wireless tech for connecting devices like headphones, keyboards, mouse, and other devices that we use nowadays. Radio frequency RFI. It uses radio waves to track and identify objects like inventory in a warehouse. And FC. We also call it nearby field in communications. It is a short-range wireless tech for contactless payment like Apple Pay or tapping credit card transactions. It's a contactless payment. It's paying by tapping your card or the phone to the NFC devices nearby for fast and secure connections as well. Now, we'll understand about the network topology. What is network topology? It refers to the layout of a structure of a network, how devices like computers, routers, and switches are connected with each other. Common types of topologies are star topologies, where all devices get connected to a central hub like a Wi-Fi routers. Bus topology, where devices share a single backbone cable like older setups. In ring topology, devices that form a closed loop where passing data in one direction, and mesh topology, where devices are interconnected like used in smart homes or offices. Now, we'll get into the details of the bus topology. Here, all devices are connected to a single central cable like a bus. The advantage is it's simple to set up, cost effective, and for small network. All devices are connected to a central hub or switches. Okay, it is easy to manage. That is the biggest advantage of the bus topology. Failure of one node doesn't affect others. Okay, but there is a disadvantage. If the main cable fails, the entire network goes down. The performance degrades with heavy traffic as well. Star topology. Here in star topology, all devices are connected to a central hub or a switch. Please remember this. All devices are connected to a central hub or a switch. The advantage is it is easy to manage, but failure of one node doesn't affect others. Unlike the bus topology, here, if the one node fails, it will not affect the others. But there is a disadvantage. Central hub failure disables a whole network, and the higher is the cabling cost of this star topology. The costing is too high. Now, the ring topology. So now the ring topology. Here, the devices are connected in a circular loop while data transfers or travels in one direction. outboard direction. It has an advantage like equal network access for all the devices, so no collisions here in this ring topology. But there is a disadvantage. If a single node fails, it can break the entire network. It is even difficult to troubleshoot. So we need an experienced network engineer to detect any issues or any trouble which is related in the ring topology, mesh topology. The entire device in mesh topology is interconnected with multiple parts, full or partial mesh. Every device is interconnected with multiple part, full or partial mesh, but the advantage is it is highly reliable, no single point of failure, but there is a disadvantage. It is expensive due to high cabling and maintenance. So always remember, mesh topology is highly reliable, but it is expensive and it is expensive to manage and to purchase as well. Tree topology. It combines star and bus topologies in a hierarchical structure. The advantage is it is scalable for large network, easy to expand. So mainly they are used in offices. Disadvantage of tree topology, it is dependent on the root node. Failure at higher level affects the lower branches. So if there is a failure at the higher level, the lower level will get affected as well. Now, hybrid topology. It is a mix of two or more topologies. For example, star topology with the ring topology or star topology with bus topology. The advantage is it is flexible, optimized for specific needs. So you can customize or optimize this hybrid topology according to your needs. The disadvantage is it is having a complex design and it is very costly to implement. Okay, so that's all for this network topic. We will get back to you with another video. Till then, goodbye and have a nice day.